Hi, in this video we will learn about so-called m-ary vectors. We will see what is the definition, how the vector operations work for these vectors, and in particular where this naming coming from. Okay, first thing is let us just recall what we have learned so far. The vectors that we have been studying so far were vectors that we studied. Well, they had components which were real numbers. So studied have real number components. So if you have vector with two components, basically it means that you need two numbers, two real numbers. And also scalars, the numbers we are multiplying to are real numbers. So not only the components are real numbers, also the scalars, the constants we can multiply to these vectors are also real number. And remember the notation. The real numbers we denoted by R. Then vectors with n components we denoted by Rn. Well, if now I replace R with something else that we can do the operation of addition and multiplication, we will get another theory for vectors. Well, this new theory won't have any probably geometric meaning, but we can add vectors and we can have scalar multiplication. So what is next step? What is the next step? Is that replace R by integers modulo m, which we denoted by zm. Then we will have vectors that have components are zm, so it means that scalars will be elements from zm. Remember, zm are 0, 1, 2, up to m minus 1. And components of the vectors are again from zm. So this will be again from 0, 1, 2, 3. Then remember the addition of vectors and the scalar multiplication were component-wise operations. So when you do the operation, you use the addition of zm. So for vector operations, use operations of zm. And then the set of all vectors with n component from zm, we will denote this thing by, well, as it was before. So I replace R by zm, and the number of components appear up there. Well, let's just, for example, see. So the example, binary vectors. So binary vectors means that when m is 2, so when m is 2, so we are working with z2, then the vectors you create by z2 are called binary. And then in that case, well, binary vectors with n components, so binary vectors of length, for example, 4 are what? So you have z2, 4 components. And what are these vectors? Well, it can be 0, 0, 0, 0, or it can be 0, 0, 0, 1. It can be 0, 0, 1, 0. And if you do all these things, you will get at the end, well, how many elements? So two options we have for the first one, 2 options for the second one, 2 options for the third one, and 2 options for the last one. So in total, z2 to the power 4 has 2 to the power 4 vectors. And the addition, for example, you can have 0, 1 added to 1, oh, with 4 components, sorry. Oops. 0, 1, and 1 and 0 is added to 1, 1, 0, 0. Well, it means what? You do operations component-wise. First component plus first component. Second component plus second component. Third component plus third component. And last component plus last component. But you have to be careful because the operations we are doing here are in Z2. In Z2, 0 plus 1 is 1. 1 plus 2 is 2, but 2 is not in Z2. I have to replace it by the remainder of 2 by 2, which is 0, and 1 and 0. So you do the operations as we had before, component-wise, but consider the operations from Zn. Or another example would be 0, 1, 0, 1 plus 1, 1, 1, 1. You multiply this, well, you just add this thing. So this will give us 0 plus 1, 1 plus 1, 0 plus 1, and 1 plus 1. The result is 0 plus 1 is 1, 1 plus 1 is 0 in Z2, 0 plus 1 is 1, and 1 plus 1 is 0. So that is where this binary vectors coming. If we use the other terminology, so what is the terminology here? Terminology. If you use Z2 with n components, these are called binary. It means that Z2 is playing role. Binary vectors of length n. When you have Z3 to the power n, we work with ternary. This is what is related to 3 vectors of length 3. And in general, for Zm, we will say m-ary vectors. Sorry, this wasn't length 3, this was length m, n here. And m-ary vectors of length n. Well, the important notation is that to understand what is going on with this indices, the lower one is modular, the upper one is the number of components. Then other than that, everything else is as before. The operations are done in Zm. Let us do a few more examples. Example 1. So what is 2 times 1 to 0 plus 1, 1, 1 in Z3 to the power how many components? 3 components. And this one 1, 2, 5, and 4 plus 3 times 1, 0, 0, 1 in where? First of all, it has 4 components, and the modular operations is done in Z6. Let's just complete this. Okay, the first one, this is a scalar multiplication. First, you do multiply all the components by 2. Two times 2 in Z3 is 2. 2 times 2 in Z3 is not 4. You have to replace 4 by its remainder, which is 1. And 2 times 0 is 0. Plus 1, 1, 1. And this gives us 2 plus 1. Component-wise, add them. 1 plus 1 and 0 plus 1. This gives us what? 2 plus 2 in Z3 is not 3 because Z3 has only 0, 1, 2. You have to replace it by its remainder, which is 0. So this is 0. Second component, 1 plus 1 is 2, and 0 plus 1 is just 1. This other one in Z6 to the power 4, well, we will do the first one plus 3 times 1, 3 times 0, 3 times 0, and 3 times 1. This gives us what? 1, 2, 5, 4 plus 3, 0, 0, 3. And this is 1 plus 3, 2 plus 0, 5 plus 0, 4 plus 3. And the operations are done in Z6. Yes. So 1 plus 4, Z6 is 0, 1, 2, 3, 4, and 5. And 1 plus 3 is 4, 2 plus 0 is 2, 5 plus 0 is 5, and 4 plus 3 is 7. 7 is not in 6, but we can replace 7 by its remainder when you divide it by 6, which is 1. So this will be what we have. So you have to be able to do the vector operations for these vectors whose component come from integers modulo m. It's called m-ary vectors.